When we look at a lake, we see it as a single entity. We do not see anything remarkable. But actually a lake is a set of many assets. In fact, a lake's assets can be divided in three major groups: assets for ecological functions, assets for social functions, and assets for miscellaneous uses. You may as well ask, what is the use of seeing a lake as a set of these many assets? Well, there are several reasons. 1. Better understanding of the various functions served by the lake. 2. Better selection of assets while designing the lake for a particular role. We will see the different roles played by a lake in a later session. 3. While designing a lake, the surrounding public is consulted for their aspirations for the lake. At this time, the list serves as a checklist, so that nothing is missed. 4. The design of all lakes can be standardized in terms of these assets. So if a lake gets a specific type of asset, then that asset must be designed to meet specific criteria. 5. Better accounting of the money that is spent after the lakes each year. When we think of the expense in terms of assets, we have a better judgment about it. This prevents wasteful spending on lakes, and ensures better governance of the funds. And 6. We can follow best management practices for each asset, both for the rejuvenation of the lake and the day-to-day management of the lake. So now let us get introduced to the lake assets. Later sessions in this course will deal with more details of each asset. The ecological assets of the lake are the most important, compared to its social assets. The interceptor channel is a large drain that runs along the periphery of a lake. Its function is to intercept any sewage that reaches the lake, and pass it to the downstream side of the lake. Thus it prevents the pollution from entering the lake. The sluice gates may be mounted at inlet or outlet of a lake. With an inlet sluice gate, we can control the quantity and quality of the water that enters the lake. For example, if the water is polluted, keep the gate closed. Also, close the gate when the lake receives adequate water. Similarly, when the lake receives excessive water, we open the outlet sluice gates to safely let out water, so that the lake does not get flooded, and its bund and weir are not damaged. A silt trap is just a spacious chamber in the path of flowing water. Because of the wider path, the water flow slows down, and drops any sediment carried by it. This sediment is periodically removed and disposed of. A debris trap is simply any net that collects floating debris, such as plastic bags and bottles. The collected debris needs to be emptied periodically and disposed of. If the inflow to a lake consists of domestic sewage, it requires an STP, or sewage treatment plant, to treat this sewage. If untreated sewage is allowed inside the lake, the aquatic life in the lake will be severely affected. Even if domestic sewage coming to a lake is treated in an STP, it still has significant quantity of phosphorus, nitrates and potassium. These are excellent compost, and so they promote wild growth of plants inside the lake. To prevent that situation, the treated sewage is passed through a wetland. The plants in the wetland absorb the nutrient, and make it suitable for the lake. A wetland is like a garden made out of aquatic plants. Instead of a wetland, a stabilization pond may be provided, which is a series of 3 ponds that treats the incoming sewage. This includes anaerobic and aerobic treatment. The lake water needs a certain amount of dissolved oxygen, so that fish can survive in the water. In nature, submerged plants and algae do this job through photosynthesis. But if these are not present in the lake, we may have to artificially inject oxygen using aerators. The aerators are of 3 types: diffusers, paddlers, and fountains. We will see how they work. The diffusers are like foam-coated perforated pipe, through which compressed air is passed. They produce a large amount of tiny bubbles, which transfers oxygen to water. Here, an array of black-colored diffusers is placed at the bottom of a tank, which is then filled up with water. The white pipe is the compressed air feeder. For smaller applications, disc-type aerators are also used. Here a paddler is shown. It has two float tanks, which keep the whole machine floating. A motor in the center rotates paddles at high speed. The splashes in water cause the oxygen to dissolve in water. Fountains are also used as aerators. They may be floating in water, or mounted on a frame. Here also, the spray of water allows oxygen to be dissolved in water. Bunds are soil embankments that hold water. Their design must follow standardized patterns and the material used to build them must pass stringent tests. Otherwise they are apt to get eroded and fail. The rock lining on the bank of a lake is important to prevent soil erosion during rains. It may have riprap or stone pitching, which is a wall built from large stones. A weir is a low dam built across an outlet of a river or a lake. If the lake water level rises above the top of the weir, it flows over the wall and passes to the downstream lake. A jack well is to draw large quantities of water from the bed. The social zone is useful for community meetings and activities. Most of the items on this list are self-explanatory, and we will cover only some items. A gazebo is a cabin with a roof, and typically used for small intimate meetings. An amphitheater is an open-air seating arrangement where street plays, debates or singing events are held. A children's play area may attract young parents to spend time together, thus promoting social integration. A kalyani is a shallow immersion area near the main lake, where idols made out of clay and plaster of Paris are immersed. After the immersion, the clay and plaster of Paris is removed from the kalyani and disposed of. This saves the main lake from the siltation and toxic paint. The lake periphery also consists of several assets, which are self-explanatory. This concludes the introduction to the lake assets. In the coming sessions, we will see the following. 1. The selection criteria. 2. The design criteria. 3. The engineering aspects. 4. The best management practices and tips. And 5. Repairs and maintenance best practices. Thank you.